Okay, so we are to Unit 3, Lesson 4, solving systems of linear equations in 3 variables. So we are going to solve 3 variable systems using algebra. We are most often going to use elimination. So I give you kind of the steps, and I'm going to read through these steps so that you have an idea of what I expect. So the first thing you want for elimination is to have all the equations in that standard form of x, y, and z in a row. So x plus y plus z in that order equal to a constant. So you don't want any decimals, you don't want any fractions. So we'll talk about kind of how to fix that if we need to. Choosing a variable to eliminate. So we'll talk about which variable is easiest to eliminate at first. And we're going to take 2 equations of the 3 and combine them to eliminate that variable. And then we select 2 different equations to eliminate that same variable as the last step. So the process of doing that, we get 2 equations with 2 variables in them each. So that makes it a lot like the problems we did in Lesson 2. And then we find that one solution, we substitute back in, and we solve for the remaining variables. So I'm going to show that in example 1. That's a lot of steps, but hopefully when we put this into practice, it makes a little more sense. So when I look at this system, I'm going to look at which variable is easiest to eliminate. And what I immediately go to is that x is easiest to eliminate. Because if I number these, think of this as equation 1, equation 2, can't write, and then equation 3. So I would take equations 2 and 3 and just add them together to eliminate x, because it's negative x and x. So if I add 2 and 3 together, that resulting equation, x's cancel, it becomes 8y, because of 5y plus 3y, plus 10z, because of 12z plus negative 2z, and then 74, because of 73 plus 1. So I'm getting x eliminated from that equation, from that system. So then I would think to eliminate x from another system is I would take equations 1 and 2. But to eliminate x from equations 1 and 2, I'm going to use a different color for that. I'm going to keep equation 1 the same. 3x minus 2y plus 4z equals 20. And then I'm going to multiply equation 2 by 3. So it becomes negative 3x plus 15y plus 36z. And that equals, and I'm going to need my calculator for that one, 73. I know it's a big number. 73 times 3. So 73 times 3. And that's 219. So that allows me to eliminate x from this system. So my equation becomes 13y plus 40z equals 239. So all of that work was just to create a system of equations with 2 variables, because then I align these up, and I know it's bigger numbers than we are used to using from our earlier lessons, but it still should be clear on what to eliminate here. It should be clear to eliminate z, because then I just have to multiply the top equation by negative 4. So the top equation becomes negative 32y minus 40z equals 74 times negative 4 is negative 296. And then the bottom is 13y plus 40z remains unchanged. It's equal to 239. And then we see the z's cancel. This becomes negative 19y equals negative 296 plus 239 becomes negative 57. If I divide that by negative 19, I get y is positive 3. And I know that seems like a lot of work to just get one of the three variables because we're essentially 1/3 of the way through right now. But the nice thing is that I can take this y equals 3 and plug it into one of my equations that I got with y and z, and I can solve that for z. So I'm just going to plug into the 8y plus 10z equals 74. Okay, so that becomes 8 times 3, since y is 3, plus 10z equals 74. So 8 times 3 is 24. 24 plus 10z equals 74. I subtract 24 from both sides. 10z equals 50. Z equals 5. So I found that z is 5. So I've got one more variable to find. I've got to find out what x is. So now that I have two of my variables solved for, I can plug into one of the three originals from the very, very beginning. So I'm going to plug into equation 3, the last one. So x remains x plus 3 times 3 because y is 3, and then minus 2 times 5 because z is 5. So this becomes x plus 9 minus 10 equals 1, or x minus 1 equals 1. If I combine those like terms, I add 1 to both sides. X is 2. So before we had xy equations, we were solving for an ordered pair. Here, we are solving for what's called an ordered triple. So the way I'd write that as a point is 2, 3, 5. That would be my solution. And maybe I should have done that in a different color to kind of emphasize that. But 2, 3, and 5. That is our ordered triple. That is our solution. So there's a lot going on there, all right? And I'm guessing you guys are going to need extra support, which is totally fine. That's what I'm here for. So in this guided practice, might take you a bit to work through these notes. And I might have to do some of this as an entire class, and that's okay. But I want to go through a few steps and then just check, all right? Because this is multiple steps, so it's kind of hard to follow. So work through it as much as you can, and I'll probably end the video after this next guided practice example, because this is very in-depth. This is very new, and it's kind of complex at first. So pause the video, try working through some of the steps, and then check in. Okay, so there's a lot to unpack in this problem. So I wanted to make it visually make sense. So I wanted to show how I eliminated at first. So I looked at this problem and I said, I want to eliminate y, because I saw that there was a negative y and positive y. So I took, if I had labeled these equations 1, 2, 3, I took equations 2 and 3. And I simply just added them together to eliminate y. So that's what I did in the red up top here. So I got 3x minus 2x, negative 8z plus 3z, negative 21 plus 13. So I got this equation, which I'm going to just leave for right now. In the blue, I took equation 1 and equation 3, and what I did with this second equation here in blue is I took equation 3 and I multiplied it by 3 to get 3y and 3y to match up, because they're already opposite signs. So I got this resulting equation, negative 2x plus 14z equals 20. So that gave me an x and z equation, a two-variable equation or system that I set up in green right here with these little arrows. And that allowed me to set this up, and I eliminated x by multiplying the top equation by 2. So I eliminate all that out, and I go to the right to show that multiplying by 2, the x's eliminate, I break it down, I get z is 1, okay? So I took that z equals 1, and I applied that to this equation in red right here, x minus 5z equals negative 8. I substituted that in, and I solved for x. I got x is negative 3. So now that I got x is negative 3, z is positive 1, I took both of those variables, those values for those variables, and I substituted them in to equation 3. And it doesn't matter what equation you substitute back into, but I substituted into equation 3, and that allowed me to solve that out and get y equals 4. So my ordered triple was -3, 4, 1. So a lot to unpack, a lot going on. I want you to take your time with this lesson because this lesson's a biggie. It's a big one. It takes a while to get the hang of. So be asking questions, be pulling me aside. Whatever you need, let me know and I will work through it with you. I'm going to show you solving these. So what I'd actually have you do right now is actually just work through a couple of the practice problems of the early ones and then come back to them. Okay? So sorry for skipping around, but you're going to come back to the notes to solve different systems with different solutions. So I'm just going to give you a few practice problems to work on right now. Make sure you're asking questions. Make sure you're using a separate sheet of notebook paper to show all that work, because this is barely enough space to show my work. All right? So you can move on to the next step in the lesson. There are 2 more pages, but there are a few more examples. But these examples take a lot of time to explain. So I want to make sure that you guys are comfortable to the notes to solve some different types of systems. I guess 1.5 more pages.